So we've got a few people here. We've got some people. So welcome to another edition of Houdini Secrets Live, sponsored by TechArt.edu. And thank you very much for coming today. I really appreciate it. Thank you for your patience with all the silliness. So today, last 2 weeks ago, we actually created a procedural tree. And it was pretty cool, but it was kind of simplistic. What we're going to do now is we're going to dive off the deep end, and we are going to do it more hardcore. Yep. More hardcore, for sure. And so what we're going to do is get things set up. So I'm going to see if I can try to bring up the old version and kind of take a look and see what we're going to do that's different. Oh, I know I said that I was going to upload the last presentation onto someplace. What I'm going to do is set things up on GitHub so you can download these projects on GitHub. I don't have that information. I haven't done it yet. I was busy playing last week, and I was rock climbing with my wife in North Carolina, and instead of working on TechArt Live stuff, sorry. But I will have this up as soon as possible. Keep checking in with the Orlando Houdini Users Group webpage, and I will have all announcements and all information there, and that will have whatever you need to know. And for any of you who are planning on taking part of the side effects classification to make University of Central Florida an official side effects school, send out your stuff. They said that they wanted seven people to put stuff in there, and they would consider 7 people good. 7 people is what we need. So we need 7 different students to put together stuff. Now, if you just graduated, that would okay. I mean, we can say that you worked on stuff when you just graduated. They're not going to really care. But what we want you to do is get your stuff in and really start making it look good. And if all goes well, we get accepted, then you'll all get Houdini licenses, which is like really cool, and they're worth like a hell of a lot of money, like a few $1,000s anyway. Who doesn't want to put up with $100,000 or a bunch of $1,000s on this? So let's get things going. Let me see if I can get, let me go ahead and share this screen and make sure that's going. Okay, ooh, look at that. I see a brand new recursive thing. So what I'm going to do is I'm going to get rid of this. And ooh, look at all those emails. I'm going to get to see personally into my life. Okay. All right, so what I'm going to do, I'm going to return back to my Foliage demo class, and then I'm going to open up my last file, which is Simple Trees. Okay, notice here, we created this very simply. I created it very simple like, and so really what this is we are following basic taxonomy structure and techniques, and so we had a trunk, and let me see if I can improve this. I'm going to unlock it, allow editing of contents, and so that way you can see this a little bit better. So we have a trunk, and then on our let me go ahead and turn off the copy leaves to bridges. Okay, I'm going to turn this off, turn the leaves off. Oh, look at that. Okay, so that turned off most of the leaves. But really what this did, we did this in 4 iterations. We have a trunk network, we have a limb network, and a branch network. So we automatically assumed we are dealing with 2 networks of trees. We have the trunk, the limbs, and the branches. And then we have the leaf network here, and it is. Notice that there's very little control that we have over these there's very little control over what we are doing. Oh, I just saw your comment on here that we are not continuing the RAS project. We're going to use the same project that we had last time, but we are going to use a different Houdini file. I was just kind of like going over everything that we did before. And now notice that this is very simplistic, but it kind of gets the point across. There's nothing really wrong with what we're doing here, but it lacks a certain amount of control. And part of the problem is I don't like the amount of control it has, and it doesn't allow for a lot of expandability. We are going to blow that out of the water today, and we are going to create lots of brand new stuff. And so what I'm going to do is I'm going to go and create a brand new, I'm going to create a brand new scene. Okay, new. Okay, discard and new. Okay. Ooh, there it is, advanced trees. Here's my lesson plan today, so you guys get to see what we're working on. Okay. Now, before we get started, I'd like to do a special call out today. I just had the pleasure and the opportunity to have to get reacquainted on Facebook with a guy named Kim Goosens. Does anyone out there know who Kim Goosens is? Any of you guys follow his stuff? Okay, Kim Goosens. Okay, now you may not have heard of Kim Goosens, but you may have heard of other artists on the network, such as Freak Hostra. And if you haven't heard of Freak, then you probably have heard of Anastasia Alpara. Well, what's the thing that these two very, very talented students have? Well, they were taught by the same guy. And that guy is Kim Goosens. And Kim Goosens is the guy who's in charge of all that, and he got him going, and so he's really the one in charge. Okay, I just got a question from Rachel today, and it says that if you wanted to participate in the Houdini Certificate, what kind of project would be good for an animator? Well, how about some animation? Some character animation. Learn how to animate in Houdini. That was one project that a student created a couple of years ago that worked out really, really, really well. And she got an internship like almost immediately, not with side effects, but she did get an internship when she did a character animation for the demo reel, and it turned out really well. Now I know that Side Effects wants to get into character animation more, so showing off your character animation skills is really good. So anyway, if you have an opportunity, check out Kim Goosens anywhere in the network, as well as if you've never done it, check out Freak Hoekstra, and especially check out Anastasia Alpara. Anastasia Alpara is really unbelievable. Her stuff is really fantastic. Go check her stuff out. Really fantastic digital modeler using procedural techniques. Now, I want to thank a former student of mine, Jerry, or Hongren Yan, or otherwise known as Jerry, for this. Jerry, if you're listening to this broadcast, thank you very much. You provided the foundation for this lecture. I gotta make an honest truth to you guys. I have never, before this Houdini series, I've never created procedural trees inside of Houdini. You know, that's the truth. Sorry. But what I did was I applied traditional taxonomy strategies, and I was able to pick up onto it really quickly. And Jerry, you provided the foundation for this lecture. Now, I used someone else's work for last week, and I'm going to use Jerry's structure for this week. So, cool stuff. So, thank you very much, Jerry. And if you happen to talk to Jerry, tell him that I'm mentioning his stuff all over there. Jerry, you're awesome. You're an awesome artist. I wish to hell that you could get your visa and come back to this side of the pond and work with us again. Go and tell your bosses that the Tech Art Live guy thinks you're awesome, and so come on back. All right. In this lesson, we're going to revisit some tree taxonomy, and then we're going to constructing some portability from original intention. So we're going to create a structure that's kind of based on what we did last week, but we're going to take a whole new direction on this. Now, here's the disclaimer. Thank you, Alejandro Perez. Thank you, Jerry. Yeah, okay. Okay, if you want to check out trees, Anastasia Alpara is the way to go. Me, I myself, I Frankenstein concepts with rules of taxonomy. Okay, tree taxonomy. What does this mean? Okay, you start with the abstract and you push towards the very specific. Okay, let's see if we can see what this looks like. I wanted to actually take a chance and see what this looked like inside Wikipedia. Aha, here it comes. Look at this. Check this out. This is list of trees and shrubs by Taxonomy Factory. And look at all this information. Do you think there's enough trees in here? Okay. Actually, in this list, there are 1,351 species. And this all has to do with kind of like the kind of trees you're dealing with, what kind of leaves they have, whether they have leaves or needles, what kind of bark they have, what kind of wood they have, what kind of reproduction functions they have, all of that. So that's all very, very, very important, really, really good stuff. And I wanted to grab just the most abstract stuff. Now, if you're going to be doing this professionally, then you're going to want to start getting into a lot of that detail, where you know that you're going to have at least one trunk, but you could have multiple trunks. You're going to know that you don't have to have any branches. So you could have branch is 0 to m number of branch levels. You know, a median branch level is, okay, branches that come off the trunk, that's level 1. Branches which come off of branches, that's level 2. Branches which come off of branches which come off branches, that's level 3. Okay, you get the point. All right. Sometimes some of the leaves, they perform photosynthesis. You know, sometimes they have needles, not noodles. Noodles growing on trees. How silly. But anyway, the needles is not just this. Okay, we're not going to implement needles in this version. You can implement this and reproduction. Well, I'm not going to use this on this version, but you've got flowers, you've got nuts, you've got fruit, you've got cones, all of that. All right. So what we're going to do with a basic tree here is we've got common elements found at many levels. You've got bark distribution and scale. Bark should appear to have the same scale regardless of size. You got the scale number of children. That means the length of the branch, the width of the branch, the number of children along the length, the start and end of the children. That means they don't start as soon as the branch starts. No. You've got to actually start the branches at some point along the branch length, and then you can going, and you get going towards the end of the child. Okay, how gnarliness, how ragged or how knotty or how twisty are these trees? We'll see if we can get to that today. And are these trees affected by gravity? Okay, we've got a random seed that you have to deal with, and all of this stuff. Now, this is, trees are recursive in nature. That means the child elements inherit from the parent, and that the small child elements are different from the parents, but they look basically the same. That is the issue of self-similarity. And the deeper you send into the tree, the more the detail actually stays the same. So that is what a recursive fractal nature is, and trees are very good examples of that. And so what we're looking at the trunks, we're going to have 0 to n number of trunks. That means we don't have to have, well actually that should be a 1, sorry. You have to have at least one trunk, but you really don't have anything. But you can have trunk seeds. But you have a trunk height, and you have trunk variations, so there might be variations on the height. The number of points, so the actual number of points inside of that, and that has an influence on the gnarliness of it, and the number of segments. What we're going to do, we didn't do last time, is put rings on the trees and actually create variations inside of the width of the tree, but we're going to start doing that. All right, we've got branches, we've got branch seeds, levels, the number of clumps. If you ever noticed that sometimes, a lot of times branches, they tend to clump up together. And so we're going to take under consideration of that. And we're going to deal with the number of branch levels. That means we have branches inside branches inside branches and so forth. And with the number of clumps, we're also going to have the branches per clump. And the number of children actually means how many branches are sitting on each trunk of that. And then we're going to deal with leaves. Each leaf is going to have a random seed. We're going to have silhouette, or the texture of the seed. And we're going to deal with deviation, height deviation, the number of leaves, and the distribution and the scattering leaves along the branches. Okay. When working in strictly procedural stuff, what we did 2 weeks ago was pretty easy. We're going to take a different strategy, because this is going to be more complicated. This strategy here of what we got to work on is something called the MVP, the minimal viable product. We're going to get that working first. Get the minimal viable product working first, and then we start focusing on the other things. So what we're going to do is we're going to return back to the Foliage Project, and then we're going to, if you haven't created a Foliage Project, go ahead and create a new project called Foliage. It doesn't really matter what it is. We're not going to work from the same Houdini file that we used last time, but we are going to use the same project. And then create a brand new scene, and then save that new scene as Advanced Trees 01. Now, this lecture, I promise you, will go on to lectures in the future, depending on how far we get today. And so we will be returning back to this HIP file in the future. Okay, let's get things moseying along here. Okay, I hope I just didn't kill that. Did I just kill my PowerPoint? No, I did not. Okay, good, good, good. All right. So, okay, I wanted to catch myself. I got back to my notes. Okay. So what we're going to do things a little bit differently today than what we did things last time. Now last time we created a digital asset, but we created a digital asset as an object. What we're going to do is create a digital object this time as a geometry. So what we're going to do here is just lay down a piece of geometry. And I'm going to call this tree dev. Oh, you know what? I forgot to do exactly what I called this. I'm going to go ahead and file. Save as, before I do anything, job, and I'm going to call this Advanced Tree. '01. Okay. In fact, let's put the date on here. This is the 06/05. Okay, so that's the date. Advanced Tree 06/05. Okay. So we've got our charge out, so let's double click and drive into that. And so what we're going to, I know that I'm going to go ahead and create a digital asset regardless. So what I'm going to do here is, before doing anything, I'm going to drop down a subnetwork. A subnetwork. In other terms, what this is a blank Houdini digital asset. And you're going, oh, that doesn't look like a Houdini digital asset to me. I know it doesn't, but what we're going to do is we're going to turn it into one. So I'm going to go ahead and rename this guy Tree Gen. Oh, I'm going to give it a capital. Yeah. Okay, it's got a capital. And then what I'm going to do is I'm going to right click Tree Gen and then go to Create Digital Asset. Okay, then this familiar window comes up. So I'm going to go ahead and get rid of the Rudy Punk, and I want to give Gen a capital because preferential to camel caps, and so my operator label is capital tree, lowercase capital tree, T tree, lowercase g gen. All right, and for this, I want to go into my job and into my HDA and click accept, but I'm not going to call it simple tree. I'm just going to call it tree gen. Okay, so it's going to store it in there. Click accept. Boom, 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 boom. Okay. All right. Not responding. Uh-oh. It better not bomb on me. Whoa! There it is. All right. Now, we've got a blank. What we're going to do is we're going to immediately start putting information in here. So let's start putting in properties right into this bad boy. So I'm going to go over here where it says parameters, and I'm going to drag an integer. Where's my integers? Here's one. I'm going to drag that right onto root, and then I'm going to call this one master seed. And my label, I'm just going to call master seed. And okay, I'm going to make sure that there's a space in there. Okay, cool. Now this is an integer, and so what we have to do is give it a default value, because whenever we pull up a digital asset, I want my master seed to have a default value. So I'm going to call this, give this a value of 238. All right, cool. I'm going to return the parameter there. So there's my master seed. And now I've got that in there. Let's start putting in, I'm going to put some folders there to give everything a bunch of so I'm going to put the folder right here. I'm going to put the folder underneath root, and then I'm going to go under this, and I'm going to call this folder shape, because this is going to hold the shape of our tree. So the name and the label both equal shape, and this is going to be the shape of our tree. Now this is different because it's not going to be our leaves. Our leaves are going to be a little separate folder that are a little bit different for that. Okay, so what we're going to do is I'm going to go ahead and grab the folder here, and I'm going to put the folder underneath shape. And so I'm going to call this first one trunk, and then trunk. And then what I'm going to do here is I'm feeling kind of lazy. I'm going to select this folder, hit Control C, and then hit Control V a couple times. Oops, but I don't want that in there, so I'm going to give there, so here. So there should be 3 copies. All right, so in this next copy, I'm going to call this one branches, enter, and I'm going to put this one as leaves. Okay, cool. Now to see what this looks like, I always love to see what this stuff looks like. I hit apply. And so now when we look at tree gen here, we look at the parameters, there's my master seed. It's sitting way over here at 238. And we have our shape folder. We have trunk, branches, and leaves. So we're doing pretty good. All right, so what we have to do now is I want to start focusing on the trunk parameters. Let's grab an integer again down here. I'm going to put it in trunk. And so I'm going to call this number trunks. Okay, well, looking through the Wikipedia, I did see that there are some trees that have multiple trunks. So I said, oh, really? I didn't know that. But evidently it's true. So you can have multiple trunks on a tree, and I think they're called bushes, maybe? I'm not sure. But they are possible. So let's go with number of trunks. And I'm sure there's somebody who's really familiar with foliage who knows their stuff on here, that they could tell me all about what I need to know. So if you have some kind of classifications in the biological terms of how trees are actually classified and can they have actual multiple trunks, please feel free to chime in. And if not, well, enjoy the ride. All right, now I've never gone over this with you, but we are going to start fine-tuning our digital asset in order to make it more professional. And part of that is that we want the number of trunks. If we want it to start with the number of 1, then we have to tell it that we want to restrict its range. So let's put the range. I'm going to click this range button, and it says 0 to 10. I'm going to make sure that it goes from 1 to 10. So that means I can have between 1 and 10 trunks. Now we can actually have more or less than that, but the interface isn't going to play nicely unless you put this stuff in. Now we still haven't created a default value because this is just the range. So if I click over here to channels, and now here's the default value. I want this to have at least a value of 1 because we at least want 1 branch going on here. So that's going to be our 1 branch. All right, the next parameter I want to put in here is a float. Where's my float? Oh, there it is. I'm going to put it under trunk, and I'm going to call this trunk seed because I want a seed value that's different from my whole tree. Trunk seed. Okay, and now what value do I want for this? So as a default value, I want 26 or 28.16. All right, we're going to be playing lots of parameters with this. All right, we need more parameters. So what we need to know is what's the base trunk height that we want to deal with. So I'm going to grab a float, put this under trunk. Grab this. I'm going to call this one trunk height. So this is basically the height of the tree. This is like where we're just going to start getting at. That doesn't mean our branches can't go higher, but this is the fundamental size of our tree. All right, we've got a trunk height here, and we want it to have a default value of 40. So our trees are actually pretty healthy. All right, so we want variation in the height. That means we want our height to create variations, over time, or we just don't want all of our trunks to be the same. We want some kind of randomness. So let's create some kind of variation. So I'm going to grab a float here and put this under trunk here, and that's going to put this there, and I'm going to call this height variation. Now, for the label, you're going to see why I'm going to do this in a little bit. I'm just going to call it var, short for variation. And there's a method for my madness, and you'll see why in just a little bit. I'm going to click over channels, give this a default value of 5. Okay, very cool. Now, the reason why we want this is because what we're going to do is we are going to append values in our interface on the same line. And in order to do that, we have to get the parent parameter, and we have to turn on a little parameter for it. So for the trunk height, I'm going to click that, and see where it says horizontally join next to parameters? I'm going to click that, and when I click apply, here's our stuff. And notice that we have number of trunks. Trunk seed is just sitting there, but trunk height is sitting over there all by its lonesome. And right next to it, what do we see? We see var. It's right next to it too. But it's not beneath it, it's right next to it, and that's because I chose horizontally join next parameter. Now, there is a groovy thing here. The height variation doesn't really mean much when there's only one trunk. Alright? So it's kind of like, well, you got the height, but there's no variation because there's only one trunk. So we want the height variation to only pop up when the number of trunks is greater than 1. Okay, and there's a way of Houdini in order to set that. So I'm going to select height variation and see where it says here disable when. I'm going to put a little expression here, and it follows this. We're going to enclose our expression in curly brackets. So open and close curly brackets. I'm going to drop into the middle there, and I'm going to put an expression that's going to try to evaluate. And if it evaluates true, the thing's going to get disabled. If it evaluates as false, then it's going to stay on. And so I'm going to say number trunks is less than 2. Okay, number trunks is the variable for our number of trunks. So when the number of trunks is less than 2, in other words 1, go ahead and disable this parameter. Otherwise, leave it on. I'm going to click apply. Now you saw that my variable parameter disappeared. Well, it didn't disappear, it just is unselectable. You can't change it. But look what happens when we change the number of trunks. It pops back on. Okay, so this disable when is a way of disabling interface devices when we create some kind of condition. And hide when also does that, but it makes the parameter actually disappear. Now that's totally cool. Alright, we still have a couple more parameters to drop in. So what we're going to do is drop in the number of trunk points. How many points along the trunk are we going to be dealing with? So let's just deal with an integer here, leave it constant. So I'm going to go trunk, and we're going to go trunk points. And trunk points. And as a default value, let's put a value of 40. This will have a significant impact when we start dealing with the gnarliness of the tree. And so let's see, we need the number of trunk segments as well. So I'm going to drag another integer here. I'll go trunk segments. Now, when we start creating rings around our trunk, we're going to need to know how many segments to our rings we want. And that's what I'm putting in here. This number of segments is basically the number of segments in each of the rings along a trunk ring. So I'm going to go trunk segments. Okay, good. We've got that on here. And we are ready to rock and roll, I think. Oh, we get to put a default value in here. Let's put 12 in there. Hit apply. Okay. Things are looking pretty good. So we've got some stuff to begin with. Now, honestly, I don't really know what are all the other parameters I need. Remember, I did that taxonomy breakdown ahead of time, and it's mostly pretty abstract stuff. But if I hadn't had done that taxonomy stuff beforehand, I wouldn't have known I needed to create these parameters ahead of time. So when you create your taxonomy breakdown of your procedural model, it tells you what are some of the parameters that you're going to be creating and what are some of the minimal viable elements that you're going to be dealing with. So always create your taxonomy breakdown before you create any procedural project. I'm going to go ahead and click accept to kind of move things over here. So let's drop into TreeGen and actually start making some trees. Okay, so we're in this, so let's just get things started. Let's just start with a line. Well, that's pretty easy. Here we have as a line, and I'm going to call this branch template. Now the reason I'm calling it a branch template is because this is going to be the template for all of our branches, whether those branches are trunks, whether they're branches, or whether there's branches within branches. We're going to make it all come from this one generator. So, no problem. But notice it's sticking up. Okay. I'm kind of cheating here. I know for a fact that I'm going to use the copy node. And the copy node kind of assumes certain things. And one of those assumptions is that if you have an object and you're going to be copying an object to a point in space, and that point has a normal, well then it's going to stick the x direction along a specific direction that's kind of predictable. And so I know that in order for all my branches to behave properly, they have to be pointing in the x direction, so when they get copied to my points. So I'm going to change my direction of my line to 1, 0, 0. So it's pointing along the x direction. And now, here we're going to start playing around this. We're going to start creating some variations. So for the length, what we're going to do is I'm going to hit Alt E. I'm going to put my cursor inside of the length parameter. I'm going to hit Alt E, and that's going to open up a little expression window. Now you don't have to do this. You could type right in that, but for visual purposes, I wanted to go and show this to you. So we're going to type in an expression, and it's CH, which stands for channel, and then what we're going to do is grab the trunk height. And the trunk height is, we're going to go up one level, and that's where the trunk height information should be. So boom slash trunk height. Okay, I'm going to hit apply. Okay, everything looks good. I'm going to drop my cursor into the viewport, and I'm going to hit Shift H to kind of home the whole thing on there. So there it is. It's moving along. So I'm going to close this, and let's just test to make sure it's working. I'm going to go up a level, and now where I have my trunk height, if I move that up and down around, okay, so I can move this up and down around here. So this moves up around here. Okay, cool. Okay, now I kind of see that I do have a problem. Here by default my thing goes from 0 to 10, and I kind of want things bigger than that, so I'm going to open up my type properties again, and where it says trunk height, I'm going to make sure the range is between a value of 0 and 100. Oops. And I'll click accept, and now this slider goes between 0 and 100 without problem. Perfect. Alright, very good. Oh, by the way, if you ever want a channel value to return to its default value, all you do is right click on that channel value and go revert to defaults, and that returns it back to its default value. Okay, now I wanted to put some kind of variation in here so that so that we're getting some kind of variableness. Because we might have multiple branches here, so I'm going to go ahead and put the cursor back in here, and I'm going to go Alt-E, and so there's my trunk height. So I'm going to play around some. I'm going to do some Houdini magic, so I'm going to go plus CH, and I'm going to get my trunk variation. So here, I'm going to make a reference to my channel, my trunk variation channel, so // trunk, ooh, it has, hey, don't I have trunk height, trunk points, trunk seed, trunk variation? Oh, look at that. I don't have it. I don't have a variable for that. Why don't I have a variable for that? Okay, I'm going to go ahead and type this in anyway. Height variation, and it's going to give me an error here because this doesn't exist. But I'm going to just go and copy this name and see. And hit apply, and it's going to say, yeah, bad parameter. Okay, fine. So let's go back and find out what we did wrong here. We're going into my type properties, and so height, oh, it's called height variation, not trunk variation. So let's go ahead and just change this to trunk variation. I click accept. Okay, nothing seems to happen, but if we go into here, into the branch template, we got rid of the warning. So it is happy now, and it's not complaining. All right, so what we're going to do is we're going to multiply this trunk variation, and we're going to multiply it by a random statement. Now, this random function returns a value between 0 and 1. And so that's why we have to scale it by the trunk variation, because the trunk variation goes 5, and we want the variation of our height to vary between 0 and 5. But we're going to put some seed values in here, and what we're going to do here is we're going to add the master seed plus our trunk seed. So we're going to do 2 CH's, CH, and open parentheses, close parentheses, double quotes, and .. master seed, and it identifies it right there. Cool. And I'm just going to go ahead and copy this and say plus, and I'm going to say instead of master seed, I'm going to go trunk seed. Okay, click apply, and you saw that it changed shape just very little bit, and that's exactly what we were hoping for. Click accept. Now, it's just to test this, if we wanted to go up a level and we wanted to play with the variation, I'm going to go expand that a little bit, and the variation will cause that to change some, and it's doing so randomly. And likewise, if we wanted to manipulate the trunk seed and move it around so it plays with some randomness anywhere along there. Okay, cool. So everything seems to be working very fine. So there's our trunk base. So where are we going to put this? Well, you got to put it on the ground. So we have to create a base for it. So I'm going to create a base for it by creating an add SOP. An add SOP is the lowliest and simplest SOP that there is, but that's okay. It is very, very useful. So I'm going to change the name of this to trunk base. And what I'm going to do is I'm going to create one point. And I'm going to click this thing here. Whoop, click it on. And so that means I'm going to, what this SOP is doing is creating one point. Where is it creating it? Right at the base. So I'm going to turn this on. And, whoa, there it is. Is it on? There it is. There's my point. There it is, itty bitty, 1 point. Here, let's turn on its number. See, there it is, 0.0. It's sitting right there all by its lonesome self. Okay, that created a point in space. Very, very, very simple. Not much. All right, now let's give this one a vector so that we can manipulate how it goes. And we want to make sure that the vector goes up. So I'm going to drag this off of here, and I'm going to go attribute create. Attribute create. Oops, come on, give me an attribute create. He's not doing what I want. Come on, he's screwing around with me. Okay, attribute create. I'm going to rename this as trunk normal. Okay, trunk normal is ready to rock and roll. And so let's call this the name of this attribute. Just give it a big old capital N. So that means we are creating the normal. All right, and for the type, let's go ahead and change this to a vector. And so on the default value, we want it to point up. So let's go 0, 1, 0, 0. So you're saying, hey, I don't see what's happening. What's going on here? Well, let's go turn on the vector here, and then let's focus in on this. I'm going to do a Shift F. Whoa. We'll have us go Shift H. Okay. What I did was I homed in on this, and it got really small. But there's my vector. It's kind of like, you see it's a little arrow, it's pointing up. So it's pointing where I want it to go now. Okay, perfect. That's what I want it to do. Well, we have our branch template and we have our base. Awesome. All we have to do now is just copy the branch to this. So I'm going to go drop a copy to stamp or copy stamp SOP right here, and my branch template is going to go right in here. That the first parameter input, my base is going to go into the copy spot, and I'm going to hit display, and it's going in the wrong direction. Joy! Okay, and let's see. I'm going to hit Shift H to make this thing. Okay, I think the reason for that is because I have transform accumulative on there. Right, we've got that going on here, and so our branch is pointing in the X direction. All right, to our normal, it's pointing in the Y direction. And it is not pointing up. Oh, joy. Let's see, what can we do in order to help encourage things? All right, what happens if I change this to 0, 1, 0? It's pointing along the Z direction now. Okay, so what happens if I point this along the Z direction? Aha! There it is. It's pointing straight up now. There you go. Now this isn't going according to my notes, and I'm sure I'm going to have to come back and change this into the future. But for the time being, let's just leave this as is. We just know that we change the direction of our line so that it's aligned with our base normal. And so it's not correct, but hey, it'll work. All right. So this works, right? Okay. So we have a trunk, and although it says 2 trunks, we only see 1 trunk. Okay, what are we going to do in order to create multiple trunks? We have one there. What we could do is create multiple bases, and then for every time that we have a base, what we could do is just copy our branch to the to whatever base is there. That sounds like a reasonable plan. In order to do that, what we're going to use is something that I don't think I've showed you folks before. It's called a for each loop. And we're going to make extensive use of for each loops. And so I'm going to go in tab and type in for each number. And so that creates actually 3 nodes. Now this is kind of a pain in the butt. I got to come up with a new kind of like meta function in order to make this simpler. But I want to change the name of all these because it says for each begin, for each count. I mean, we're going to use a bunch of for each loops by the end of this lesson, and we got to change the name in order to avoid getting confused. So I'm going to change the name of this first one where it says block begin. I'm going to change this one as trunks underscore begin. Then I'm going to change this one to trunks underscore count. And then this one, I'm going to go to trunks underscore end. Okay, I'm going to give you a little lesson about how Houdini for loops work. They're really good, They work really well, but they can be kind of clunky if you're not familiar with it. Let's start with, believe it or not, the end. Okay, the end, this is like where the for loop finishes. And the for loop finishes right here, and we have to tell it how we want it to finish. Now the gather method. Now this is like, okay, we're gathering input. We have to tell it how we want to gather the input. And so so what we're going to do is leave the gather method as merge each iteration. So that means every time we go through the loop, we want to merge whatever happens or wherever gets created. We want to merge it together. But we want our start value to go at 0 here because we want it to start at 0. I don't like, I've been programming in C++ and C for so long. I'm so used to starting all of my loops at a value of 0 that I want to just continue doing it. I can't get it out of my head. But the number of iterations depends on the number of trunks that we wanted to do. So let's put in an expression here that calls that value. So I'm going to hit Alt-E to bring this up again so you guys can all see it. So you have ch, open parentheses, close parentheses. I'm going to drop into that. Open quotes, double quote, close double quotes, and inside I'm going to go ... / number trunks. There it is. All right, cool. Except, so it says we want the number of trunks in here. All right, cool. Now, the for loop keeps track of where all the loops are for us. Isn't that fun? Now, you start that by going over here to the beginning node. Notice that we've got a strand going from the beginning to the end, and they're all connected to each other. So the begin node, that tells us how to start keeping track of the information. For what this was, we want to keep track of fetching metadata. Okay, what is metadata? Well, metadata is the data that the for loop keeps track in order to keep track of, like, what's the current loop at, how many iterations are we going to go through, blah, 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 blah. And so that's all called metadata. So how do we know what that metadata is? If we go over here to the count, we can go to fetch metadata, fetch feedback, fetch metadata. We're going to leave this as fetch metadata. And then we're going to put the display, everything's going to disappear on my trunk's end. Notice here that it still says metadata, so I'm going to go with fetch feedback and change this back to fetch metadata and change this to feedback or fetch metadata. And now we see that it's all related to 1. Now gather here says that we only have 1 iteration, but it keeps track of the iteration because we started at 0, so we only have 1, so therefore the iteration value is at 0. Where do we see this information? And what we wanted to catch this information, if you look over, select trunks count, and I'm going to do is come over here to and add another window here. I'm going to go to inspectors, geometry spreadsheet. I'm going to come all the way over here to the detail tab. And now here we can see this is where the data is kept. We can see that the current iteration is 0, the integer value is 0, and the float value is 0.0, and the number of iterations is just 1. So because that's all we're actually going to have, the number of iterations. Okay, so that's what's keeping track of this. So the 3 of these will keep track of all of our passes together. All right, so let's go ahead and see if we can try to hook all that stuff together. So what we're going to do is put in the trunk base . I'm going to put this in here, right into here, and then I'm going to put trunk normal and put that into here, and then I'm going to put copy, and I'm going to make sure to hook in. No, I don't want that node. I want it to come to here, and so that our branch template still goes into the first one, and trunk normal comes into there. Okay, so what we've done is we've put the add trunk base into the first step of the thing, first step of the loop, and then we create a trunk normal for it, and then we're going to create a copy for it over into the branch node. All right, let's test to see if this all works. So if we come up here, go up there, go to tree gen, and say number of trunks, we put that to 2. Okay, did it complain? Well, nothing seemed to complain, and we said the metadata here, the gather here, and we go ahead and crunch this. It says gather equals 2, but the metadata says, so that means it's 1. So actually, how many objects do we have here? It's really hard to tell because they're all sitting on top of each other. So what I'm going to do is I'm going to click this and then go to my geometry spreadsheet and say, okay, points. Okay, we actually have 4 points in here. We have 0, 1, and 2, 3. And that means we have 2 primitives. We have the 0 primitive and the first primitive. So it actually worked. So this generated the number of copies here. But the problem is they're sitting on top of each other right now. And that's not good for anybody. So what we have to do is we're going to have to change things around a little bit. And so I'm going to get rid of this trunk normal. I'm just going to go ahead and delete this because we want something else to go in here. What we want in here is an attribute randomize. So attribute randomize. Oops, come on. Attribute randomize SOP. I'm going to drop that in here. All right, and I'm going to call this trunk normals because this is like more than one here. All right, now this is what's going to give us our kind of like our spread a little bit. Okay, so my attribute name, I'm going to put this to n, because then we want it to be the normal. But no, look at this. It's now pointed in some wacky-ass direction. Okay, and there's a reason for that. It looks like our minimum value, our x value, and so these minimal values are controlling each of the sides. So what we have to do now is come over here to where it says options. Now it says global seed. Now we're going to change global seed from 4086 to something else. And we're going to take into consideration the count number and the seed number and the master seed. So let's go ahead and change that. So I'm going to drop that in here. I'm going to hit Alt-E. I'm going to get rid of 4086. And the first thing I'm going to do is we're going to keep track of the iteration number. Remember that count is keeping track of iteration for us. So what we're going to do is in order to access that information, so I can access that information by typing detail, which is the name of a function that will access that kind of information. So detail, and then I'm going to give the location of my node that I want the detail from. So I want it, I'm going to go to trunk, and this was trunk underscore trunks count. So trunks, there it is, trunks count. All right, that's my object that I want. Okay, I have to tell it which parameter I want. I want iteration. And I had to give it a default value. I'm going to call it 0.0. So that means if something goes wrong and it can't find that, what value should it use? It uses iteration. Okay. Now this is fine. This is going to give us a value of right now 0 or 1, right? Because we have 2 iterations. But that's still not going to give us a randomness that we're looking for. So what we're going to do is we're going to throw in our master seed and our trunk seed, just to kind of vary things up a little bit. So I'm going to go plus ch, open and close parentheses, open and close double quotes, and I'll go dot dot master seed, and then I'm going to add the trunk seed. Oop, that's mastered seed. There's no such thing. Thank you. Just give me confirmation. And so what we're doing is trunk seed. All right, trunk seed. There we go. All right, so I'm going to hit apply. Oh, look at that. Okay, I have multiple trunks and they're going off in their own wacky old directions. I'm going to play with this around. So the number of trunks, if I go under here, then I got 3, 4, 5. Okay, look like, okay, we've got a whole bunch of variations. But these variations aren't very tree-like. They're not cooperating. There's too much spread. You know, but honestly, they're trees. We want them kind of focusing up. We're going to deal with gravity, but just not quite yet. And so what we have to do is we have to, tell it, how much spread to have. So we're going to add some more information into our type properties. I'm going to right-click into here and go Type Properties. And so what I'm going to do is I'm going to create some kind of visual separation in this, because we've got the number of trunks, we've got the seed, we've got the height variation, the trunk points, and the trunk segments. Okay, this is all good. So let's go into the spread information. So I'm going to grab a separator. I'm going to put this over here on trunk. Okay, just going to put the separator right there. And we don't have to name it anything. It's just going to create a visual separator. And then what we're going to do is, I kind of like say, well, I'm going to create a new floating point. And so where's a new float? Float. Oh, there we go. I'm going to add this right up at the top of it, and it's going to put right underneath there. And I'm going to call this trunk spread. So this is going to control how much we spread. So trunk spread. And get this trunk spread. Okay, now I want trunk spread to kind of like hang out with trunk variation. So what I'm going to do is I'm going to drag my trunk variation variable and I'm going to put it right next to that in the separator so that these two are together. And yeah. Okay, so trunk variation, so number of trunks. Where was that? Trunk seed, trunk height. Okay, so trunk height variation. Okay, I'm going to get rid of that horizontally, so these two are together. But what I'm going to do is where it says trunk variation, I'm going to correct horizontally next to parameter, and I'm going to copy this expression, and then where it says label, I didn't put it. I'm going to put the disable here. So there's, and wow, this should be trunk spread. Alright, so what I did was I just updated the label there. That should have been there. But what I did was I put this condition here on the disable when so that it would turn this variable off when it was not needed. Okay, and so we've got that in the type, and okay, so we've got that going great. Let's see, do we have to have some kind of default values? For our trunk spread. Let's keep it small. Let's keep this the spread small. Let's go and give it a value of 0.1. That might be too big. Let's just apply it and see what happens. Okay, we got that. So I'm going to click apply. And you see here what it is. So here's our variation and here's our trunk spread. Now with the number of trunks, now if we move the number of trunks over to 1, okay, so these turn off, so now if we turn it off onto the 2, then we have our variation and our trunk spread there. Var is here, but trunk spread, we don't see spread there, so I'm going to change the name of that. So where it says trunk spread, I'm just going to just to spread. So it makes a little bit more sense. Does this look better? Yeah, spread. Okay, the interface looks a whole lot better. It's a lot more readable. Okay, now let's go ahead and start putting this. Now inside of this trunk normals, this is where we're going to put our stuff. I'm going to put my trunk spread information right here for the minimum values. Now, I always want this to be pointing in an upward direction, all right? So my minimum value is always going to be 0, and my maximum value is always going to be 1. So I always want to point it straight up. So let's leave it at that. But I know that our spread, my x value can go in the negative direction and can go as positive. And so we're going to put the spread values here for the minimum and the negative and the maximum values. We're going to put the negative values in the minimum and the positive values inside of the maximum. So in other words, I'm going to do, just type in here ch, open parentheses, close parentheses, open quotes, close quotes, and I'm going to go / trunk spread. Yeah, that's what I'm looking for. And I want the negative version of that, so I'm going to put a negative there. Okay, so we have the negative trunk spread. And so that's negative 0.1. Okay, cool. So what I can do here is I don't want to type all that stuff in again. So I'm going to double click this and hit Control C. So that's going to copy the whole parameter. And then I'm just going to hit Tab twice. This is the Y value. Now this is the Z value, and I'm just going to hit Control V. And when I click somewhere that's arbitrary, you'll see that it copied that exact same channel to there. Now, what I'm going to do is I'm going to go ahead and drop that into the max value for X. I'm going to hit Control V, and I'm going to get rid of that negative because I want it positive. And then I'm going to come over here to the Z, and I'll type that in, and I'm going to get rid of its negative value. So it's positive. Okay, cool. Now let's look at this. It's now, we've got two trunks kind of like pointing straight up-ish, but they're slightly deviated from each other. Okay, let's see what happens if we add the number of trunks. Okay, so this adds. Okay, we got one outlier. That's kind of strange. I'll have to. Might come back to haunt us in the future, but we're going to leave that for the now. Okay, but check this out. We have some variation in the angle of our trunks, but our trunk length is all the same. So we have to put some variation inside of our branch template in order to take into consideration variable length of our trunks. And those of you already familiar with Houdini might say, oh, okay, I know what he's going to do now. He's going to use a copy stamp. The copy stamp process. And you are absolutely right. Give that man or woman a cigar. Okay, so I'm going to click copy here. And we've got the copy here. Now we are going to create a variable inside copy that we want to send to branch template that will tell branch template how much to scale each one of its copies. Okay, follow along with me if you can. Press copy, and now in the copy SOP, I'm going to go to where it says stamp. Now I'm going to go press this before I forget, stamp inputs. So that basically means let's turn it on. So once we've turned it on, we're saying, okay, good. Stamp inputs equal true. We're going to create a new variable here, and we're going to call this trunk length. Okay, and now here's the value. Now it is dinky here. So what I'm going to do is I'm going to put my cursor in here and hit Alt-E to make it bigger so that we can see what I'm going to type here. Now I'm going to type in a bunch of stuff, but really what I'm going to do is create a bunch of randomness. Okay, so first thing I'm going to type is a CH, open and close parentheses, open and close quotes. Okay, this is getting kind of, you see the pattern here? And so what we're going to put is trunk variation, so it's / trunk variation. That's it right down there. Okay, cool. Now I'm going to put in a random statement. So times, here's my trunk variation, and rand. Now remember, rand returns something between 0 and 1. So I've got rand statement and in parentheses, 0 and 1. So let's put in the seed values. Now, each one of these seed values, is going to create a specific point. So we've got 1 point, 2 point, 3 points. The number of points we're going to create there. So we want to keep track of the number of points. And so in order to get that information, it's called $PT. So that's the number of points. That's the current point number that we're currently working on. Okay, well you might say, okay, well smarty pants, how the hell did you figure that out? Okay, check this out. You click on the copy SOP, and you click this little question mark, and aha, the Houdini help window comes up. And there it is. It tells how to use the Houdini stuff, and it works there, and it says how to instance this stuff, blah, 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 blah. Okay, now here, local variables. This shows you all the variables that you have access to from the copy SAP, and this shows you what you can access. And so all this groovy information is available to you inside of the copy SAP. So this is where it is, and this is what we're going to use is PT, which is the point number of the template being copied to. If there is a template group, this will be the index into the group, not the actual point, blah, 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 TPT, instead of getting the actual point number. No, we're not going to be using a template group, so we're just going to use $PT. Okay, $PT is what we've got here. Now we're going to add more information to that. So we're going to add the master seeds, and we're going to use the trunk seeds. So CH, open close parentheses, open and close quotes, dot dot slash master seed, and then we're going to add the trunk seed. Okay, I've changed that trunk seed. Okay, so I'm going to hit accept. Okay, it didn't give me any errors. And let's look at this. Let's close this. All right. Okay, so is this working? Well, hopefully it is. Okay, now look at this. This value is going to be a value of 1. Or, I'm sorry, it's always going to be positive. How do I know this? Close. I'm freaking out here. All right, there we go. I'm going to go ahead and access this. All right, there we go. All right, so it's going to be a trunk variation. It's going to be like 5. It's going to start off, and it's going to be multiplied by some number between 0 and 1. Now, suppose I wanted to actually go, instead of going from 0 to 5, I wanted to go from negative to 5 to 5. Okay, what that means is that we're going to have to take this rand value that's between 0 and 1. If we double that to go between 0 and 2, and then subtract 1 from it, then the result of this rand will be go from negative 1 to 1. And so when we multiply our trunk variation for it, instead of going from negative 1 to 1, it'll go between negative 5 and 5. So let's go ahead and then put parentheses around this rand function, and then multiply it by 2 to double its length. So now the rand goes between 0 and 2, and then let's subtract the value 1 from it. And actually, I put this parenthesis in a little bit far. So what I'm going to do is I'm going to remove this parenthesis. So I'm going to go 2 times rand directly. And then I'm going to move this parenthesis outside the negative 1 here. And then I'm going to put this parenthesis outside the 2 here. All right. So hit apply. Okay. Now, if I hit the value, or left mouse click the value, and it says it's a negative 1.4. Okay, so that means it can go in the negative or the positive direction. Okay, that's sweet. Now we've generated this tree length variable. Well, what do we do with it? Well, let's go back up here to the branch template, and where it says length. Oh, we already have a big old expression here. How do we integrate that? Jeez Louise. Okay, so what we're going to do is we've got our trunk height. And then we have our trunk variation times rand times master. Okay, now that trunk variation and all that is now stored within our trunk length variable inside of our copy set. So what I'm going to do is I'm going to get rid of all of this. And then I'm going to access my variable inside the copy. So I'm going to go stamp. So it's going to access that and open close parentheses. Now, the stamp takes 3 parameters. The first parameter is the SOP node that I'm copying from. So I'm going to open and close quotes. I'm going to go dot dot slash copy 1. Oh, is that what I named it? I'm going to have to change that. Okay, then I have to express what the variable name is that I created, and it's called trunk length. Trunk length. Okay, I have to put one more parameter in here, and that is a default value, so in case something fails, it has a value to fall back on. So I'm going to click apply, and no errors. So let's click a look at that, and let's see what we got here. Okay, so here we go into that, accept there, trunk length. All right. And here we go. Are we getting a variation? Yeah, they're varying slightly. So let's see if we increase the number of trunks. If we where's our height variation? 4.1. Okay, so it's doing it all proportionately, so it's still not working yet. Okay, so we've got our copy value here. And so that means that our stamp value here is coming up with trunk length. Okay, so what is our name of our variable here in there? Trunk length. And do we have this right? Okay, $PT plus, okay, we've got that. We've got $PT, except. And then we have here trunk length, copy branch of points. Oops, that's not what we want. We want the trunk length. Trunk length. Okay, now I've obviously typed something wrong in here because it is not copying this. Now this should be varied. Now if we so if we go length 40, it's always the same. Okay, plus state that, so that means that this value is coming across as 0. So let me change this name here. So I'm going to call this copy to branch points. Copy to branch points. All right, let's see here. Copy to branch points. That did it there. So they're talking to each other. Now, why aren't you working for me? Did we remember to stamp our inputs? Okay, we come up here, transform accumulative. Is this turned off? Okay. Transform using template point attributes? Okay, we got to turn that back on. Preserve normal length. Okay. Cache stamp, pack geometry. Okay. Now, anyone out there know what's going on? Because I'm having demo-itis here, and I can't remember what I did wrong here, but I've done something wrong here. Technically, that should work, and we should get a variation in the length of the length of the branch. And this is a normal time is when I would halt the video, figure out what I did wrong, and then come back. But now I've got to entertain everybody, so what's going on? So I have to figure out what I did wrong here. So what I'm going to do is, I don't know what I did wrong. So if you were by yourself and you were going along here and say like, oh, gee, Chris, I've never used this copy thing before. How do I know how to do this before? Well, I'm just the same as you. And then I goof up and I make mistakes as well. And so what I'm going to do is I'm going to figure this out pretty much exactly the way I would do things otherwise. I'm going to work this out the long, hard way. Okay, so let's keep things simple here. So let's say that we want a just have a line here. We want a line, and so let's just say we have a line here that's going along the x direction, 1, 0, 0, and let's create the distance of this line, the length of, oh, let's give it a length of 10, and we have 10 points. Okay, we got 10 points along there. Okay, groovy. Now suppose we wanted to copy a sphere on every one of those points. So let's go ahead and hit sphere. And I just want to go ahead and create some kind of variation on the radius of the sphere. So I'm just going to create a copy stamp. And I'll put sphere here, the copy there, and voila! There we have it. Let's, okay, I'm going to keep this, so we have these big spheres here. And so what we're going to do here is I'm going to create a copy here. I'm going to turn off transform accumulative, going to stamp inputs, and then I'm just going to create a variable called here, foo. Okay, foo. And then what we're going to do here is put just RAND, random, and then I'm going to take whatever point number, say $PT. Okay, so we've got some kind of random number coming in here, $PT. Okay, this is going to give us a value somewhere between 0 and 1, right? And it's going to 0.82 at this moment in time. All right, but that doesn't mean anything. So let's put that operation here in for the sphere where it says uniform scale. So I'm going to go stamp and open parentheses, and I'm going to go double quotes, and I want to have the ... / copy 1. All right, and then another parameter is going to be the parameter I want, and I think I called it foo. And we have some kind of default value, which in this case would be 0. All right, there we have it. It's working, seems like it. We've put random variables inside each of these things. Isn't that cool? All right, so I've done something wacky, and something is nutty here, but which I do not know. So what I'm going to do is see if I can somehow get this one that I know is working. And I'm going to go and put this on here. So I'm going to go in and put this copy over here. And this input into here. And put this guy into there. So what I'm going to do is hook that one up because I know that this one's working. Okay, so all I have to do is hook up this branch template to use the right word. Okay, so if we have, what's my copy here? We have rand PT, that's fine. So what we're going to do is put that here, it's a value of foo. So here it is, I'm going to go trunk height plus copy that. No, I'm just going to say that I want it as copy 1. Okay, copy 1. And so my trunk length, I'm not going to have trunk length, I'm just going to call it foo. I'm going to go ahead and enter that. Okay, and what's my value? Okay, 40. Okay, so this really doesn't want to cooperate with me. Okay, the trunk base. Oh, no, okay. So what I have here is how many points do I actually have here? So we should have 4. So how many, do I have 4 points in here? Because it seems like I only have 1. Okay, here, I've only got 1 point. Okay, well that would be the reason why. Okay, so it seems like I was doing everything right all along, and I was just like spazzing out. Okay, so the problem was something entirely different. So I'm going to rehook this one back up. So I think I'm not smoking crack. I think what I was doing is right. Okay, so what I have here, so trunk base is just 1 trunk. Oh, this is just 1 trunk. Here we go, trunk normals, and we go there, and then copy to branch points. Okay, so that should be working correctly. Dimensions 3, okay. Set value, guess from group. -2, okay, that's fine. There it is. What am I doing wrong with this? This is indeed a predicament. All right, now we're running out of time here, so I will have to continue this conversation next week. But before we just abandon everything, I'm going to come back to this next week. But what I wanted to show you before we get moving along here, and we'll get to this, I promise you, we'll come to the end of this. Ooh, actually, here's a warning. Maybe this will tell us what's going on here. Bad parameter reference, copy 1 in reference. Oh, okay, copy 1, okay, so it's not accessing copy 1 here, it's copy to branch to points, so, okay, so, copy to branch points. Okay, there it is. Now we got rid of everything. I'm going to hit Control S just to save everything in time here. All right, now just make believe for a little bit that this had all worked. I'm going to get rid of these. Now let's see, you guys out there in La La Land are probably looking over and saying, oh, I know what he did wrong, he's just not able to see it. But, oh well, let's just keep going and keep going on variations. So, we've got this. Now what if we wanted variations? We've got multiple trunks. Now let's start creating multiple levels. And so our multiple levels should go on here. And you know what? I'm going to have to make an executive decision here. We have only a certain amount of time, and I don't really want to go over. And so I don't want to leave this point on an error. So what I'm going to do is we are going to continue this lecture next week. We've got a good point there, and we're at a good point, and I'm going to go ahead and resume right with how to fix this thing on next Friday. And what we're going to be doing next Friday is we are going to be recursively adding branches onto these trunks, and then we're going to add branches onto branches. And so we're going to recursively go into this. Now, that structure is a little bit complicated, and I think I want a little bit more time to go into that. So maybe this is actually a good place to take a break. So, with that said, thank you very much for your patience, thank you very much for your patience. I really appreciate it. And tune in next week when we will continue this, and then we will continue more of the branch. We'll get branches within branches, and then we will actually start putting bark on the top of the tree and get that worked out. And maybe if we have time, then we're going to go with additional leaves as well. So we're really moving things along. So tune in next week. Thank you very much for your patience. If you like what you see, go ahead and go ahead and like this broadcast. If you want, go ahead and subscribe to the web channel, and then go to the for those of you who are into the Houdini, the Orlando Houdini users group, welcome. Go to the Orlando Houdini user group page inside of Facebook, and go ahead and sign up and join the group. And you will get lots of information pertaining to all things Houdini. Now, we just got our certification as far as the meetup group is, so we will be having a meetup group. As soon as bars open up, we're going to have a Orlando Houdini user group meeting almost immediately. And we're going to meet at one of the bars, probably maybe over at the Ace Cafe. And we're going to have a quick little social get-together. And I want you guys to tell me what you guys are all interested in, what your ambitions are, why you're using Houdini, and what I can do in order to help bring all this information to you. So come on those with that. Subscribe and join the Orlando Houdini users group, and we'll keep you up with information. So thank you again for all of your patience. Thank you again for your participation and your patronage, and we will see you all again next week. And until then, arrivederci.